In this video I want to pay attention to the so-called Circard circuits that are on worldradiohistory.com, and if possible I will give, say, a link in the text box. I know that this is a safe link, so I'm more or less sure that YouTube will pick it up. Be okay with giving that link, etc., etc. It's all about this book that is on the radiohistory.com website. And the good thing of this book is that it is bare essential. It gives really the best information when you want to develop electronic circuits. Though, of course, it's a book of the 1970s, so we live now 2023. A lot of things have changed, but of course physics have not changed, and also electronics physics have not changed. That means that you can find here a lot of very interesting and good circuits where you want to do experiments, and these are the authors of this book, etc., etc. 1975, so a long time ago, of course, but it is, like I say, still not obsolete. Absolutely not obsolete. Here are the contents. Basic active filters, comparators and Schmidt triggers, waveform generators, AC measurements, audio circuits. So a lot of information, and like I told, the best thing is that they show practically tested circuits with all the ins and outs, so that you can also, say, do adaptations. For instance, this interesting, at least I pick up one of the items, constant current circuits, power amplifiers, etc., etc. A-stable circuits, the A-stable multivibrator will surely be there, micro power circuits, etc., etc. The preface, well, you can read it surely on the website that I have named. Of course, this book is, say, a kind of sea to drink. So anyway, I cannot say focus on all the say interesting things that perhaps are interesting in your case or in other cases. Basic active filters. Well, I will flash over all the say things that are illustrated here. The Wien-Bridge bandpass filter, the Wien-Bridge all-pass network. Well, of course, with a Wien-Bridge oscillator there is a kind of standard filter network. And I will skip this all very quickly. Here are, say, a few types of filters. This is a typical band filter. It's say tuned to a certain frequency. Here's a slope. Here's a falling slope, a slope that's going up. This is a typical notch filter. Here, this is a notch. So on a certain frequency, all the energy is brought down to zero, etc., etc. And of course, like I told, you can find this book completely free, by the way, on the World Wide Web. Well, of course, there are advertisements. I cannot go too deep in detail, but for instance, this is a very good example of how good this info is. Wein bridge bandpass filter. And when you know something about the Wein bridge, you know that there are in fact two parts of that filter, two legs in a certain way. They are combined, and that gives a very sharp peak on a certain frequency. And the good thing is also here that we also have the formulas, and the good thing is also that simple op-amps are used. Many times the 741 op-amp is used, so it's a cheap op-amp. Perhaps it costs 20 cents or 50 cents, etc., etc. And you can do many experiments with that and make such a filter. Only one example. And all the good thing is also that they show circuit modifications here. Well, Wein bridge all pass network. Here you see again the two legs of the filter. And I'm gonna skip now very fast because I am on 6 minutes of my camera. Voltage controlled filters. Well, that's of course also very interesting, I think. With a voltage you can control, say, the pass band of a filter. Many say very good ideas are showed that are really made in the past and really work. I'm gonna skip, etc., etc. So twin notch, that's very interesting. This is a typical notch filter, and this is also the typical way of how a notch filter is made. Like I told, it presses down all the frequencies on a certain frequency. That depends on this part of the filter. This is typically for a notch filter, but now it's made with a 741. But when you know a little bit about electronics, you can also find circuits where one transistor or two transistors are used in combination with this type of filter. This is a T-notch filter. And here you see the notch. Anyway, I'm gonna skip. Sorry for all this very quick skipping. Comparators and Schmitt triggers. Well, that's always interesting, of course. Comparators are often used with the help of op-amps. The good thing is that in this booklet they use, say, the first op-amp of those op-amps of those days, 1970s, Schmitt trigger, bipolar clamping, basic Schmitt trigger, etc., etc. Well, this is of course interesting. Let's see. This is of course an advertisement. Anyway, they tell here how a comparator and Schmitt trigger work. With all the mathematics, I have to say confirm me to the mathematics, but my knowledge is in electronics is purely practical. So anyway, of course always very interesting to see how all these things around Schmitt triggers and comparators are explained, say, in a mathematical way. Well, here are some things. Bipolar clamping, I don't know what it is, so I skip it. There are of course many interesting things to tell. This is the basic Schmitt trigger circuit. When you have studied or watch my videos out of the past, You will surely have seen this circuit. This is the basic Schmitt trigger circuit. By the way, important to tell, in my Schmitt trigger circuit it acts on a tiny DC voltage change here, but now here in this case they send in a high frequency, say around 100 kilohertz, and that means that the Schmitt trigger switches on, in this case, on approximately 100 kilohertz. But the whole principle is the same. The two emitters are connected here. That's very important. This is a bridge. The second transistor has a high value resistor from base to ground, to 0 in this case. And it means that, say, with such a Schmitt trigger, you can change, say, sine waves into square waves, at least when we are talking about a high frequency circuit. But when you can also use this when you leave this capacitor here, but it can do no harm on the other hand. You can also use here a tiny voltage, positive voltage in this case, because these are NPN transistors, a positive voltage, and on a certain moment you will see that the Schmitt trigger switches when a certain voltage is reached, and the voltage goes somewhat higher than the voltage that makes the first transistor switch. Anyway, and you can also see here how that works. This is the waveform and where it switches. And of course there's a lot of information here in these Circards, in that Circard book. Circuit modification, well, etc, etc. Frequency may be increased to 300 kilohertz if the drive voltage is increased to 4 volt peak. Well, that's also, say, an important thing. Anyway, I will again skip and skip and skip. Perhaps I can find another circuit that is, this is perhaps interesting. I don't want to pay attention to that now. I will high speed Schmitt trigger. That's also very interesting, of course. Schmitt trigger gives also a certain time delay, and due to, for instance, this diode, and this refers also to other circuits, say the multivibrator circuit. With a diode, you can make the Schmitt trigger reacting on higher frequencies. Anyway, skipping and skipping and skipping. Reference controlled hysteresis circuit, very interesting, of course. Window detector, say, I think this has to do with the lowest voltage and the highest voltage where a circuit has to switch. But of course I have to study it. And of course after studying it, waveform generators, well, that's interesting, of course. Typical waveforms can be generated. I'm sure that my camera will stop suddenly. Sorry for that. I will go on as far as I can. Advertisement, basic op-amp square triangle generator, very interesting. So, sorry when my camera suddenly stops. I can talk endlessly about this book. It's very interesting. Very interesting. Uni-junction transistors are often used for all kinds of generators. And in older books of the 1970s, you will often find the uni-junction transistor used as as an oscillator. I never made a circuit with a unijunction transistor, by the way. So let's leave it. I'm now on 15 minutes. Very interesting here. Voltage controlled square triangle generator, etc., etc. I've made this circuit and published it on YouTube. Perhaps when I have time and can find it, I will give the link. This was my inspiration source of this circuit, and I made this circuit when I tried to make and afterward successfully made a very simple oscilloscope going to approximately 20 kilohertz. Thanks for watching. This was all. Perhaps I'm going to do a new video about it, but about this book. It's extremely interesting and you can learn a lot, and it gives also a lot of inspiration.